July 26, 1944. 30,000 feet above Munich, Germany. Flight Lieutenant Albert Wall banks his de Havilland Mosquito PR Mark 16 into a violent evasive turn as something impossible streaks toward him from below. The silver blur approaching at incredible speed has no propeller, no engine noise, just the distinctive whistle of Germany's newest weapon, cutting through the thin air at over 500 miles per hour. Wall's navigator, Flight Officer Albert Loben, grips his seat as their wooden wonder shudders under the stress of maneuvers that should tear apart an aircraft built entirely from plywood and balsa wood. Behind them, Lieutenant Alfred Schreiber, in his Messerschmitt Me-262, closes the distance with technology that represents a 20-year leap forward in aviation. Germany's first operational jet fighter versus Britain's paper plane that critics once dismissed as a furniture maker's folly. What unfolds in the next 18 minutes will leave German officers stunned and questioning everything they thought they knew about aerial superiority. The encounter that begins with Germany's most advanced interceptor pursuing what appears to be easy prey will end with the wooden bomber escaping into Italian clouds, carrying photographic evidence that will reshape Allied understanding of German jet capabilities. But to understand how Britain's supposedly obsolete reconnaissance aircraft outmaneuvered the world's first operational jet fighter, you must first grasp the extraordinary story of an airplane that should never have worked, built by a man whose radical vision challenged every assumption about bomber design. The saga begins in 1938, when Geoffrey de Havilland walked into the British Air Ministry with a proposal so unconventional that officials initially dismissed it as technically impossible. At a time when military aircraft demanded increasingly heavy armor, defensive armament, and metal construction, de Havilland suggested building a bomber entirely from wood that would carry no defensive guns whatsoever. His reasoning seemed dangerously naive. Instead of fighting enemy interceptors, his proposed aircraft would simply outrun them. The DH-98 Mosquito would be so fast that enemy fighters couldn't catch it, eliminating the need for protective systems that added weight and drag. Critics called it Freeman's folly, referring to Air Chief Marshal Sir Wilfrid Freeman, who championed the project against widespread skepticism. The Air Ministry's resistance wasn't entirely unfounded. Previous fast bomber concepts had proven vulnerable when enemy fighters evolved to match their performance. Germany's rapid advancement in fighter technology suggested that any speed advantage would prove temporary. Moreover, wooden construction seemed antiquated when aluminum alloys offered superior strength-to-weight ratios for modern aircraft. De Havilland's team persisted because they understood something fundamental about aerodynamics that their critics missed. Wood could be shaped and finished to achieve surface smoothness impossible with riveted metal construction. The Mosquito's monocoque fuselage, built from laminated plywood over a balsa core, created an aircraft with exceptional aerodynamic efficiency that more than compensated for any weight disadvantages. The construction process itself represented a revolution in aircraft manufacturing. Fuselage halves were molded in concrete forms, ensuring perfect symmetry and surface quality. Wings used a similar technique, with plywood skins bonded to wooden frameworks under controlled pressure and temperature. The resulting structure was lighter, stronger, and more easily repairable than conventional metal aircraft. Powered by two Rolls-Royce Merlin engines producing 1,100 horsepower each, the prototype Mosquito first flew on November 25, 1940. Test pilot Geoffrey de Havilland Jr. immediately recognized that his father's vision had been vindicated. The aircraft achieved 392 miles per hour in level flight, faster than contemporary fighters including the Supermarine Spitfire Mark V and Hawker Hurricane. More importantly, the Mosquito demonstrated handling characteristics that contradicted assumptions about wooden aircraft performance. Instead of the sluggish, unresponsive behavior critics predicted, the bomber proved remarkably agile. Its low wing loading and efficient control surfaces provided maneuverability that approached single-engine fighter standards while maintaining the speed and range of a twin-engine bomber. Initial operational deployment began in September 1941 with photo reconnaissance missions over occupied Europe. The first combat sortie, flown on September 17 by squadron leader Rupert Clerk, demonstrated the aircraft's potential when Clerk evaded three Messerschmitt Bf-109 fighters at 23,000 feet through superior speed alone. The reconnaissance variant, designated PR Mark I, carried cameras in place of bomb loads and featured extended fuel capacity for deep penetration missions. Stripped of all unnecessary equipment, these aircraft could cruise at 400 miles per hour at altitudes approaching 35,000 feet. German fighter pilots found themselves repeatedly frustrated by targets that disappeared before effective interception could be achieved. Bomber variants followed in May 1942, carrying up to 4,000 pounds of ordnance while maintaining speeds that made interception extremely difficult. The Mark IV bomber could deliver precision attacks against strategic targets while avoiding the heavy losses suffered by conventional bomber formations. Early operations achieved remarkable success rates with minimal casualties. Fighter bomber versions entered service in early 1943, armed with four 20mm Hispano cannons and capable of carrying bombs or rockets for ground attack missions. The FB Mark VI became one of the most versatile combat aircraft of the war, equally effective against aerial targets, ground installations, and shipping. Its combination of speed, firepower, and agility made it ideally suited for precision strikes behind enemy lines. Night fighter variants transformed air defense capabilities over Britain and Europe. Equipped with airborne interception radar, the NF Mark II could locate and engage enemy bombers in complete darkness. The aircraft's quiet operation and excellent handling characteristics made it particularly effective for these missions. By war's end, Mosquito night fighters had claimed approximately 600 enemy aircraft, plus 600 V-1 flying bombs. German response to the Mosquito threat evolved slowly as Luftwaffe commanders struggled to develop effective countermeasures. Standard fighters like the Messerschmitt Bf-109 and Focke-Wulf FW-190 possessed insufficient speed advantage for reliable interception. Modified versions with enhanced supercharging could catch Mosquitoes under ideal conditions, but such encounters were rare and usually inconclusive. Special Luftwaffe units, including Jagdgruppe 25 and Jagdgruppe 50, were formed specifically to combat Mosquito operations. These units received priority allocation of the fastest available fighters and trained extensively in high-speed interception techniques. Despite these efforts, German success rates against Mosquitoes remained disappointingly low throughout 1942 and 1943. The introduction of nitrous oxide-boosted Messerschmitt Bf-109 G-series aircraft in late 1943 provided German pilots with their first realistic opportunity to engage Mosquitoes effectively. These modified fighters could achieve speeds approaching 430 miles per hour in short bursts, sufficient to close with reconnaissance variants under favorable conditions. However, the Mosquito's operational advantages extended beyond simple speed comparisons. The aircraft typically operated at altitudes where German fighters performed poorly, used unpredictable routing to avoid interception attempts, and possessed sufficient agility to evade attacks even when caught. Most critically, Mosquito crews received extensive training in evasive maneuvers specifically designed to exploit their aircraft's unique performance characteristics. The tactical situation changed dramatically in spring 1944, with the operational deployment of Germany's Messerschmitt Me-262 jet fighter. This revolutionary aircraft represented a quantum leap in performance, capable of speeds exceeding 540 miles per hour and operational altitudes approaching 40,000 feet. For the first time since the Mosquito's introduction, German pilots possessed a clear technological advantage. The Me-262's performance specifications seemed to render the Mosquito obsolete. German test pilots achieved maximum speeds of 541 miles per hour during trials, nearly 150 miles per hour faster than the fastest Mosquito variants. The jet's service ceiling exceeded 39,000 feet, well above normal Mosquito operating altitudes. Most ominously, the aircraft's acceleration and climb rate made it capable of intercepting targets that had previously been considered unreachable. Lieutenant Alfred Schreiber of Erprobungskommando 262 became the first jet pilot to engage Allied aircraft in aerial combat when he encountered Flight Lieutenant Wall's Mosquito on July 26, 1944. The engagement began when German radar detected the lone reconnaissance aircraft approaching Munich at 30,000 feet, flying a standard photo mapping mission over southern Germany. Schreiber launched from Lechfeld Airfield in Me-262, prototype number 130,017, climbing rapidly to intercept altitude. The jet's powerful Junkers Jumo 004 engines accelerated the aircraft to maximum speed within minutes, positioning Schreiber for what appeared to be a routine interception of an obsolete propeller-driven bomber. The initial attack approach proceeded according to standard fighter tactics, with Schreiber positioning his aircraft behind and slightly below the target to minimize the Mosquito's opportunity for evasive action. At a range of 800 meters, he opened fire with the Me-262's quartet of 30mm Mk-108 cannons, weapons capable of destroying any Allied bomber with a few hits. Wall's response demonstrated why Mosquito crews were selected from the RAF's most experienced pilots. Instead of maintaining course or attempting to outrun the jet, he immediately initiated a series of violent evasive maneuvers that exploited the fundamental differences between jet and propeller aircraft performance characteristics. The Mosquito's low wing loading and responsive controls allowed instantaneous direction changes that the heavier, less maneuverable Me-262 couldn't match. While Schreiber possessed superior speed and climb rate, Wall could turn inside the jet's turning radius and execute rapid altitude changes that disrupted the German pilot's attack geometry. More critically, the Me-262's early Jumo engines suffered from throttle lag that prevented rapid power adjustments during combat maneuvering. Schreiber found himself repeatedly overshooting his target as the Mosquito executed unexpected turns that his jet couldn't follow. The wooden bomber's ability to change direction instantly contrasted sharply with the jet's requirement for wider turning radii at high speeds. The engagement continued for 18 minutes, as Schreiber made 6 separate attack runs, each foiled by Wall's superior knowledge of his aircraft's capabilities. The Mosquito pilot used every trick developed during 3 years of operational experience, including split S maneuvers, barrel rolls, and climbing turns that forced the jet pilot to choose between maintaining attack position and avoiding structural damage from excessive G-forces. During the final attack sequence, Schreiber attempted to engage from below, hoping to use the Me-262's superior climb rate to achieve a more favorable firing position. Wall countered by diving toward cloud cover at maximum speed, exploiting the Mosquito's excellent high-speed handling to escape before the jet could reposition for another attack. The encounter revealed critical limitations in early jet fighter technology that German engineers had not anticipated. While the Me-262 possessed overwhelming performance advantages in straight-line speed and climb rate, its combat effectiveness was severely compromised by handling characteristics that favored high-speed interception over close-range maneuvering combat. Schreiber's post-mission report described a target that seemed to anticipate his every move, executing evasive maneuvers that prevented effective weapons employment despite clear technological superiority. His assessment influenced German tactical development for jet fighters, emphasizing the need for different attack techniques when engaging highly maneuverable propeller-driven aircraft. Wall and Loban's escape carried consequences that extended far beyond a single successful evasion. Their aircraft had been running cameras throughout the encounter, capturing detailed footage of the world's first operational jet fighter in combat. The photographic evidence reached Allied intelligence within hours, confirming rumors about German jet development and prompting immediate reassessment of Mosquito vulnerability. The response to these revelations led to development of the Mosquito PR Mark 32, a specialized high-altitude reconnaissance variant designed specifically to counter the jet threat. This aircraft featured extended wings, enhanced superchargers, and weight reduction measures that increased operational ceiling to 42,000 feet, above the service ceiling of the Me-262. Additional modifications included pressurized cockpits for crew survival at extreme altitudes, enhanced oxygen systems rated for extended high-altitude operations, and improved cameras capable of effective photography from 40,000-foot altitude. The PR Mark 32 represented the ultimate evolution of the Mosquito concept, pushing wooden aircraft technology to its absolute limits. These high-altitude variants proved remarkably effective against German jet interception attempts. Operating above 38,000 feet, they flew in atmospheric conditions where early jet engines performed poorly, and human limitations severely challenged German pilots. Even when Me-262s managed to reach interception altitude, the extreme operating environment degraded their combat effectiveness significantly. The tactical revolution extended beyond simple altitude considerations. Mosquito units developed new operational procedures that exploited jet fighter limitations, including unpredictable routing, multiple altitude changes during single missions, and coordination with weather systems that provided natural concealment. These techniques proved so effective that German success rates against high-altitude mosquitoes remained minimal throughout the war. German countermeasures evolved continuously as more Me-262s entered service with specialized units. Oberleutnant Kurt Welter of the 10th Staffel Nachtjagdgeschwader 11 became the most successful jet pilot against mosquitoes, claiming 25 night victories and 2 daylight kills while flying the Me-262. His success came primarily from developing new tactics that emphasized patience and positioning over the aggressive pursuit methods that had failed during early encounters. Welter's approach involved using the jet's speed advantage to position for single devastating attacks rather than extended maneuvering combat. He learned to exploit the mosquito's predictable behavior during photo reconnaissance missions, positioning his aircraft along likely flight paths, and attacking during moments when evasive maneuvering was limited by mission requirements. Despite these tactical improvements, German jet fighters never achieved decisive success against mosquito operations. The combination of limited aircraft numbers, fuel shortages, and pilot inexperience prevented systematic implementation of effective countermeasures. More fundamentally, the Mosquito's operational flexibility allowed continued mission success even when individual aircraft were lost to jet interception. The broader implications of Mosquito versus jet encounters influenced post-war aviation development in unexpected ways. The wooden bomber's ability to compete with revolutionary jet technology demonstrated that aerodynamic efficiency and operational flexibility could partially offset raw performance advantages. These lessons informed early jet bomber design, emphasizing handling characteristics and mission adaptability over maximum speed alone. Manufacturing considerations also proved significant. While Germany struggled to produce sufficient quantities of complex jet fighters requiring exotic materials and precision manufacturing, Britain maintained steady Mosquito production using readily available wood products and conventional assembly techniques. The wooden bomber's manufacturing advantages became increasingly important as wartime material shortages intensified. By late 1944, Mosquito production had reached its peak efficiency with multiple factories producing aircraft using standardized techniques developed over 3 years of continuous improvement. The distributed manufacturing system proved remarkably resilient to bombing attacks, with production continuing even after direct hits on major facilities. The aircraft's maintainability in field conditions provided additional operational advantages that became apparent during extended operations. Mosquitoes could be repaired using basic woodworking tools and locally sourced materials, while Me-262s required specialized facilities and factory-produced components for most damage repair. This difference significantly affected operational availability rates in forward deployment areas. Combat loss statistics revealed the ultimate measure of the Mosquito's success against advanced German fighters, including jets. Despite facing increasingly sophisticated opposition throughout the war, Mosquito units maintained the lowest loss rates of any aircraft type in RAF Bomber Command Service. The combination of speed, agility, and operational flexibility proved more effective than any defensive armament system. Post-war analysis conducted by the Royal Air Force determined that Mosquitoes had proven 4.95 times more cost-effective than heavy bombers when applied to precision bombing missions. This remarkable efficiency ratio reflected not only the aircraft's inherent capabilities, but also the tactical advantages gained from its unique performance characteristics. The influence on subsequent aircraft design extended throughout the early jet age and into the supersonic era. The Mosquito's emphasis on clean aerodynamics, multi-role capability, and operational flexibility became standard features of successful military aircraft. Even modern stealth fighters incorporate design principles first demonstrated by de Havilland's wooden bomber. Hermann Göring's famous statement about the Mosquito revealed the psychological impact of Britain's wooden wonder on German leadership. "It makes me furious when I see the Mosquito. I turn green and yellow with envy. The British, who can afford aluminum better than we can, knocked together a beautiful wooden aircraft that every piano factory over there is building. They have the geniuses, and we have the nincompoops." The comment reflected deeper frustrations within German military leadership about resource allocation and strategic priorities. While Germany invested enormous effort in developing revolutionary but complex technologies like jet fighters, Britain achieved comparable results using simpler, more practical approaches that could be implemented rapidly and maintained easily. Adolf Hitler's obsession with the Me-262 as a vengeance weapon rather than a defensive fighter exemplified the strategic miscalculations that prevented effective exploitation of German technological advantages. Resources diverted to fighter-bomber variants could have produced larger numbers of pure interceptors capable of systematically countering Mosquito operations. The final irony of the Mosquito versus jet encounters emerged in post-war service comparisons. While the revolutionary Me-262 was retired immediately after Germany's surrender, Mosquitoes continued operational service until the mid-1950s. The wooden bomber's practical advantages in reliability, maintainability, and operational flexibility proved more valuable than the jet's spectacular performance specifications. The last Mosquito rolled off production lines in November 1950. 7,781 aircraft after the first prototype flight. The final variants incorporated all lessons learned from encounters with German jets, representing the ultimate development of wooden aircraft technology. These aircraft influenced the design of their replacement, the English electric Canberra jet, which adopted many Mosquito operational concepts. Flight Lieutenant Wall and Flight Officer Laben's encounter with Lieutenant Schreiber on July 26, 1944 demonstrated that technological superiority alone cannot guarantee tactical success. The wooden bomber built by piano makers had outmaneuvered the world's most advanced fighter through superior training, tactical flexibility, and operational wisdom. The lesson resonates throughout military aviation history. The most successful aircraft are not necessarily those with the highest performance specifications, but rather those that best integrate technological capability with operational requirements. The Mosquito's ability to evolve continuously throughout the war, adapting to new threats while maintaining its core advantages, exemplified this principle. German officers remained stunned by encounters where their most advanced interceptors failed to achieve decisive results against wooden aircraft built using 19th-century materials and 20th-century techniques. The contrast between revolutionary jet technology and traditional wooden construction seemed to violate basic assumptions about technological progress and military effectiveness. Yet the Mosquito's success against jets validated de Havilland's original vision of an aircraft that achieved superiority through intelligent design rather than brute force application of advanced technology. The wooden wonder proved that innovation, properly applied, could triumph over raw technological advantage when combined with superior tactics and operational flexibility. On that summer day in 1944, 30,000 feet above Munich, the future of aerial warfare was being written by two very different approaches to the same challenge. Germany's jet represented the triumph of engineering excellence and revolutionary technology. Britain's wooden bomber embodied practical innovation and operational wisdom. History would ultimately judge which approach proved more effective in the crucible of aerial combat.